Hey everyone, so in this video we're going to take a look at a tool called HashiCorp Packer. And if you don't know what Packer is a tool that allows you to create custom images that can be used to be deployed on AWS, Azure, GCP, VMware, Docker. It's got a lot of different supported platforms, and so it makes it very easy to modify any base image, pack any different configurations and source code and applications into an image so that you're able to deploy a finalized image that has everything that you need onto the image, so you don't have to go in and manually modify or configure or manage your servers. Instead, you could just deploy a finalized and complete image. So what is Packer? Well, Packer is a tool that's used to create images for multiple platforms from a single source configuration. And what exactly does that mean? Well, if you take a look at any different platform, let's say AWS, for example, when you want to deploy a virtual machine or an EC2 instance, you'll grab a specific AMI. And this AMI is a blueprint or a template that's used to configure virtual machines or EC2 instances. So they have all of the things that's actually going to be configured on the EC2 instance when you deploy them. So you take this blueprint and then you use the configuration to then deploy as many EC2 instances with that specific specification. And every other platform has this as well. So if you're working on Azure, they have their own images that can be used to deploy virtual machines. And if you're using Docker, then you also have images which are going to contain all the specifications for the containers that they can create. And so what Packer does is it gives you the ability to customize your own images. So you could actually build out your own images that are going to have exactly what you want in them, with all of the necessary processes, configurations, packages, and dependencies all installed on them. So with Packer, what we can do is we can generate configurations for an image. So what we can do is we can actually define everything that we want baked into an image. So we can have all of the necessary packages and upgrades set up. We can configure all of the necessary dependencies. We can copy all of our source code for our specific applications onto the image, and also start up any necessary services for our applications to function. And so with all of these instructions, we can then create our own custom image that can be then used on all of the varying different platforms like AWS and Azure. Now, when Packer runs, there's going to be 3 stages. There's going to be the builder stage, followed by the provisioner stage, and then lastly, you're going to have the post-processor stage. So let's take a look at all of these 3 stages in action. So the first stage that starts off is the builder stage. Now, builders are responsible for creating the image. So they're kind of like the most important piece. They are there to actually create the customized image. And depending on what platform you're working on, you're going to be using a different builder. So for every platform, there's a different builder. If you're working on AWS, you're going to use the AWS builder. If you're working on Azure, you're going to work on the Azure builder, because they need to be able to, work with those specific platforms. So they have to understand the APIs of those platforms. And with these builders, what you want to do is you want to specify a base image or a source AMI. And so what that is when you want to create a custom image, you have to start off with the base image. In this example, we're going to grab the default Ubuntu AMI provided by AWS. We'll use that image to then modify it and create our custom image. And what the builder does is it'll go to AWS. It'll take the source AMI or base AMI that you specified, which is Ubuntu in this case, and it's going to deploy an EC2 instance. So at this point, nothing special has really happened. All Packer has done is it's just deployed an EC2 instance from a pre-existing AMI. But where the flexibility of Packer really comes in is after the EC2 instance has been deployed, we can then provide a set of instructions to customize the VM. So we can provide instructions to add extra packages, install our application, set up firewall and security rules. And the section where we are specifying all of these different rules to modify that virtual machine, this is going to be done in the provisioner section. So the provisioners are used to provide instructions to configure and modify the machine that we've just deployed. And after we've made those changes to the EC2 instance or the virtual machine, there's a functionality in most cloud providers where we can then take that virtual machine, take a snapshot of it, and then create a brand new AMI that includes all of the changes that we've made. And so now we've got our own custom AMI that Packer has generated. And after that image has been created, the post processors run. So these run after the builder and the provisioners have run and can be used to upload artifacts, compress, and repackage files and images. And so Packer can do all of this with one single config file, and by running one single command, Packer will actually perform all these operations for you, really simplifying the whole process of creating your own custom images. So now that we understand what Packer is, I want to talk about what Packer or how Packer actually fits into the bigger solution of deploying an application, right? To really understand the bigger picture, we need to take a look at the way applications used to be deployed and the way that they're starting to become deployed nowadays. And we have to talk about a concept of mutable and immutable infrastructure, because you're seeing the old traditional method of using kind of go away, and people are moving more towards the immutable infrastructure, and it really highlights how Packer can be so useful in that scenario. So let's quickly just discuss what mutable infrastructure is. So with mutable infrastructure, this is kind of like the old way of deploying an application. You would first develop your application, so you'd write out all your code, and then eventually when you go to deploy your application, you're going to have to spin up a server. And once you've spun up a server, it could be physical, it can be a virtual machine. You would have to install some operating system, and this is going to be some flavor of Linux probably, like CentOS or Fedora or Ubuntu. You're then going to have to install all the necessary packages and dependencies. You'll then have to secure and harden your server, so that's going to be like setting up the firewall and all the other security rules. You'll have to then install your application and get it started. And then finally, over the course of the lifetime of your deployment, you're going to have to perform routine patches and upgrades and maintain your server. And the thing I want to highlight is this is called mutable infrastructure because you deploy your server, and then when you perform these different changes, like installing an operating system, performing upgrades, you're mutating your deployment, right? You've created a server, and then you're making changes to it. That's what mutate means. It means to change. So you deploy, mutate, and change. And that's the important thing when it comes to mutable infrastructure, is that after you've deployed it, you continue to make changes on it for the course of its lifetime. Now, with a mutable infrastructure, over time, you're going to make changes to your application. Or maybe you need to make changes to, some of the packages that are, deployed onto your server. When you need to make these changes, and this could be, like a security hotfix or something like that, you'll connect to the server and make those changes. So not a big deal if you have one server, but imagine if you have hundreds of servers. Making these changes one by one to all of these servers would be a very difficult task. And most likely you would introduce a lot of errors, and most likely you'll make some mistakes as you go across hundreds of different servers. And so this is going to open you up to things like config drift, where, some changes have been made to one server that may have not been made to the other server. And you'll see that over time, the little minor differences that you've mistakenly made on servers is going to start to grow and grow, and it's going to start causing problems in your application that are going to be very difficult to troubleshoot, because you don't know how each of these servers is configured, because, there's going to be human errors, and over time, those errors start to build up. Now, we can mitigate some of that by making use of a automation tool like Ansible that will connect to all these servers and make all the necessary changes, but even then, there's still a possibility of some, differences in configurations, because ultimately, we are continuously making changes to different servers, and over time, that does expose us to issues of config drift and things like that. And that is kind of one of the main drawbacks to using a mutable infrastructure. So the order of operations when it comes to mutable infrastructure is we create our code, we then deploy it onto a server, and then we make the necessary configuration changes to the server. Now, when we start to move towards an immutable infrastructure, what's going to happen is we're going to swap these two. So what we're going to do is we're going to create the code, we're then going to configure the server, and then we're going to deploy the server. Now, you might be thinking, well, this doesn't exactly make sense. How do we configure a server before we deploy it? We have to deploy it so that we can actually connect to it and then make the changes. Well, this is where Packer is going to come into play. This is where custom images come into play. So what we could do is we could take our application code, and we could take all of the configuration changes that we would need to make to a server, and we could take it and combine it into a single image using a tool like Packer. And Packer can then create this final image that we can then use to deploy that has everything the server needs to actually work. All of it's baked into an image, so once we deploy it, we're done. We don't have to make any other changes. It's finalized. And that's kind of the idea behind immutable infrastructure, is that you don't change it. Right? Once you deploy it, you're done. All right, so let's take a look at what this workflow would look like in an immutable infrastructure using Packer. So let's say we've developed version 1 of our application. We'll then use a tool like Packer to create a image that's going to have our source code, as well as all of the necessary configuration changes that we may need on our server, and create a version 1 image. And when we go to deploy our server, we just deploy it using that new image. And so we'll just deploy all of those instances with that same image. And at that point, we're done. You don't even need to connect to the server to make any changes. The image has all of the necessary changes already baked into it. You don't have to touch the servers. You don't have to make changes. You don't have to mutate them. That's why it's called an immutable infrastructure. Now, over time, let's say that we make some changes to our application. Maybe we add a new feature. We're eventually going to create a second version of our code. And at this point, what we would do is, once again, we would use a tool like Packer to create a version 2 image. So this is going to be a new image that's going to have the changes in our source code, as well as any other changes in any of the other packages or libraries or dependencies that we may need for this new code to work. And so you might be thinking, okay, we're using immutable infrastructure. We can't touch or change the servers that have already been deployed. How do we actually get version 2 image? It's very simple. We just deploy new instances using the version 2 image. So this new instance is going to have all of the new source code and all of the changes. And we'll just deploy as many instances as we need. And after we've successfully deployed them, we can then remove the older versions. And so that's how you successfully upgrade your infrastructure to a new version, by just deploying a brand new image. The benefit of this is that we don't have to worry about config drift. We don't have to worry about connecting to servers and making changes. We don't have to worry about anything getting mismatched. We know when we deploy a specific image to a server and we deploy that to all the other servers, they're all going to operate identically because they're all running the same exact image. And that's really one of the benefits of immutable infrastructure. And that's what Packer really allows us to do by allowing us to customize these images so that we don't have to mutate our servers after we deploy them. Now, to get started with Packer, you're going to have to first install it. So head on over to developer.hashicorp.com/packer/downloads. This is going to contain all the instructions for installing Packer on whatever operating system you're using. But after you've got that set up, go ahead and open up your favorite text editor. I'm going to be using VS Code. And FYI, if you do happen to be using VS Code, HashiCorp, or Packer more specifically, uses a syntax language for all of their configuration called HCL. And if you're using VS Code, they actually have an extension that HashiCorp has provided that provides a lot of syntax highlighting. It's not necessary, but it does make working with the language a little bit easier in your specific text editor. And I'm sure they have the same extension in all the other major text editors. But after we do that, let's go ahead and configure our first script that's going to create a custom image. Now, what I ultimately want to do in this example is I want to create a custom image for the default Ubuntu AMI on AWS that will have Nginx pre-installed on it and already have a firewall set up to allow ports 80 and port 443 for HTTP and HTTPS. All right, so I'm going to create a file for the configuration. So I'm going to do new file, and I'm just going to call this aws-ubuntu.packer.hcl. So we just need to make sure the extension, the .hcl, is there. Now, the first thing that we have to do is we have to type in Packer, and within here we have to type in required plugins. And here we're going to provide a list of the different plugins that our configuration needs to use. Now, I didn't cover anything about plugins in the slide. So what is a plugin? Well, since HashiCorp Packer has to be able to connect to AWS or whatever cloud provider you're working on so that they can actually deploy a VM, customize it, create an image out of it, and then they need to have the logic for working with the API of those specific cloud providers. And if you ever worked with any of the other HashiCorp tools, the way they do this is they keep all of that logic for working with those APIs in their own respective plugins. So if you go to the documentation here, we can actually take a look at where or what plugins we specifically need. So under the Builder section, if we go to Plugins here and say we want to work with Amazon EC2, which is what we want to do, because remember, we want to create an AWS AMI. Here, we have a couple of different options here for the Amazon AMI builder. You have the Amazon EBS, which is the builder that's used for creating EBS-backed AMIs. They have a couple of other ones, so if you just want to create an instance store AMI, they have this as well. But we want an EBS-backed AMI, and this is going to contain all of the necessary configs that you'll need for working with this. But if we go back, actually, it shows you how to use this plugin. So the plugin is called Amazon, and we have to provide two things. The source, which is copied directly from here, and then we also have to provide the version that we want. And so I'm just going to grab the latest version, which is version 1.2.1 at the moment. Let's go back to, actually, I'll just copy this here. Okay, so here we set the required plugins to be Amazon, and I'll say version 1.2.1, just to make sure we get the latest one. So that's all we have to do from the plugins perspective. And at that point, we should now be able to talk and interact with the AWS API with no issues. Okay, so we've got the plugin set up. Now the next thing that we have to do is we have to configure our builder. So here we say source, and then we provide the name of the builder. Now that's going to come from the documentation. And like I said, we're going to be using Amazon-EBS. So we say Amazon-EBS. And then you have to give this builder a name. You can call this whatever you want. I'm just going to call this Ubuntu, but this is just a name for our reference so that we can refer to it throughout the rest of this configuration file. And then we have to do our open and closing curly braces. So what properties do we have to pass in here? Once again, I recommend you take a look at the documentation. So if we go to Amazon-EBS, there's a whole bunch of optional configs, but we want to focus mainly on required configuration. So we have to provide a AMI name. So this is going to be the name of the AMI that we're ultimately going to create. So I'll do AMI_name equals, and then I'm going to give this whatever name. So how about my first Packer image? Now, a couple of other things that we can specify, and a lot of these are optional, but like I said, when we run this configuration, it's going to create a EC2 instance so that we can make the changes and then create an image out of it. So we could specify the instance type that we want to use. And here we can use, I'll just use T2 micro. We don't really need a big EC2 instance for this. You could specify the region you want this deployed to, which is US East 1 in this example. That's what I'm going to use. Then we have to provide our source AMI. So the source AMI is going to be the base image that we're going to be used to customize. So we'll say source_AMI. And now we have to get the ID of the specific AMI that we want. So I'm going to go to my AWS console, and I'll go to EC2, and I'll go to instances, and I'm going to just select deploying a new instance just so I can get the name of the AMI. And I'm going to search for Ubuntu. And here I'm going to grab the AMI for Ubuntu Server 2204 LTS. Keep in mind, depending on what region you are on your account, your AMI might be something different. It might change over time. So make sure you search it yourself and get the actual ID instead of just copying it from this video. And we'll paste that in there. Then on top of that, after the EC2 instance is deployed, we have to provide it the username to actually connect to the EC2 instance. We'll do SSH_username. And the username here is going to be Ubuntu. That's just because if you've ever worked with the default Ubuntu AMI, the default user is Ubuntu. If you're using some other image, make sure you know what the name of the username is so that you can provide it to Packer so it knows what to connect as. This is going to vary on a per image basis. If you use the default Amazon Linux AMI, I believe the default name is EC2-user, so just something to keep in mind. And then finally, there's one more thing that we have to provide this builder, which is security credentials. So how exactly does Packer actually talk to the AWS API using our account? It's going to have access to our AWS credentials. So let's go to the documentation and let's take a look at the different options. So if I go back to the plugins page for AWS, it's going to show you the different authentication methods that we have. So we can pass in static credentials where we can literally hard code it into our configs, which is going to look like this, which generally not the recommended approach just because you don't ever want to store your credentials on your config. But if you're just kind of doing this for labbing purposes and just for learning it, that's okay. But you could use all of the other methods that the AWS CLI uses. So if you want to set environment variables, you can also do that. So if you want to set key ID as well as the secret access key as a environment variable, then it can use those to connect. Also, if you want to use the shared credentials file, which is the same thing that the AWS CLI uses, you can go to your home folder. Under .aws folder, you can create a credentials file and just store it in there like that. But I'm going to just do it the wrong way, which is storing it in my config file here just so that you guys can see it. So we're going to provide the access key, and then we want to provide the secret key as well. So that's all we need for the AWS or the Amazon builder configuration. That's all secured right here in this block. Now, if you wanted to also create an image across a lot of the other different platforms, so if you wanted to be able to create an image on AWS as well as Azure, as well as GCP, well, you would just do the same thing. So you would do source, and then you would grab the name of the builder for Azure, and then, call this something like Ubuntu Azure. Then you can provide all the configs on the Azure side. So then you can create an image across all of those platforms, all right here within one Packer config. So that's really where the power of Packer comes into play. In this case, we're just going to stick with AWS, so I'm not going to define any other builders. But after we define the builder, we then have to define the build section. So we're just going to give this a name. This is just some arbitrary name for what you want to call this build. I could just say my first build. This is more for just like logging purposes. And then you have to specify sources. So what's the sources? This would be the list of all the builders you want to use. Remember, we just have one builder here. So we're just going to provide the name of that builder. And if you've ever worked with HashiCorp products, anything HCL specific, the way that this works is to reference this builder here, you would take source and then do a period, then Amazon-EBS, and then a period, and then Ubuntu. So it's going to look like this. You would do source dot Amazon-EBS dot Ubuntu. So you're just combining these three things and then putting a dot between them. So that's how you say, oh, I want to build this. And if you have any other builders, just do a comma and then just add the other builders. All right, so we've got that set up. Now, the next thing that we have to do is define a provisioner. So this is where we specify all of the different configs that we want made onto that EC2 instance. And if we go back to the documentation, we take a look at the different provisioners. We have this shell provisioner, which allows us to run different commands on the command line on the EC2 instance so we can make modifications. So doing things like installing Nginx and setting up the firewall. So this is what we're going to make use of. And so here I'll just do provisioner and I'll say shell. And then here we're going to use inline so that we're just going to provide a list of commands that we want to run. This is going to take a list. And then here we just provide all the commands that we need to modify our image. And remember, I said I want to install Nginx and set up the firewall rules. So what will we do to do that? Well, first thing we would have to do is update everything. The next thing we'd have to do is do a install of Nginx. Then we want to make sure that we enable Nginx. And just to kind of speed this up, I'm just going to copy the other commands. So after that, we'll then start Nginx. We'll then set up our firewall rules. So here we're going to allow port 22, port 80, and port 443. That's for SSH, HTTP, and HTTPS. And then finally, we have to actually enable the firewall. So the first line configures it. The second one enables it. So this is just a list of commands that we send to that EC2 instance so we can modify the image. Then after that's done, the post processors run. So after the image gets created, the post processors run. You can take a look at the documentation for the different post processors that are available. But I'm just going to use a couple as an example. So I'll do post processor. And then there's one called Vagrant, which will take the image you created on AWS, and it will also create a Vagrant box for you so that you can use it locally as well. And what's cool is that you can use multiple post processors. And so what this does is it'll take the output of the first post processor and it'll send it to the input of the second one. So the first one creates a Vagrant box. It'll pass that into the second one. The second one is a compress processor, which is going to compress that Vagrant box. So it'll create a zipped up file of that. So we'll go to our terminal and we'll take a look at the different Packer commands that we have. So if I do a Packer init and then dot, so that's saying the current directory. And keep in mind, my terminal is already in the directory this file's in. What this is going to do is this is going to initialize the plugin. So it's going to download the source code for the plugin so that we can actually, communicate with AWS. The second command we have is Packer fmt dot. And so this is going to format the source code. So if you add, like a lot of unnecessary spaces and the curly braces aren't lining up properly, you can do a format and it's going to format that brace back into the correct spot. Then if you want to validate your configurations before you run it, you could do a validate. And it's saying that unsupported block type, post processor, what happened here? And I realized just a simple typo, this should be a dash. So it caught that mistake for us, which is good. So let's try this again. And it says the configuration is valid. That's exactly what we want to see. All right, so we're going to go ahead and build our image now. And what I want to do first is, and if you're following along, go to the instance page in your AWS console. And right now I have a whole bunch of terminated instances, but notice how there's no running instances. All right, I really want to highlight that it's actually just spinning up a server for you and making those config changes. So if we go back to our terminal now, to build our image, we run a packer build and then the name of the file. So that's going to be the aws-ubuntu.packer.hcl. And take a look at the logs. So first of all, it's going to look for the source image. It's going to create some key pairs for you so that you can connect to the server. It's going to set up the security group to allow port 22. And then here we can see that it created an instance with an instance ID that ends in AD3. So if I go back here, hit refresh, you can see that we have now one in a pending state. That's the AD3. So it's actually starting up a EC2 instance for us so that it can actually create our custom image. And so now it's going to wait for that instance to come up, and it's going to wait for it to be able to SSH to it. So right now you can see it's waiting for an SSH connection. And now it's connected to SSH, and we'll scroll up. And so here you can see it's going to run the provisioner that we ran, which is going to be the shell script with all of the commands that we provided. And then it's going to run that. And so we'll just give this a bit. It's going to take a little bit of a while, especially since we did a sudo apt update. We're going to have to wait for all of that to go through. I'm going to pause the video and then we'll touch base once that's complete. All right, so it looks like the packer build command is complete, and I just want to quickly go over the logs so we can understand what happened. But here you could see the provisioners running. You could see it's enabling the firewall rules. And then at the end, it's going to say that it's going to stop the source instance after it's already provisioned it and created the image. You can see here waiting for the instance to stop, creating an AMI image that we gave with the name of my first packer image from instance blah. And then here you can see it's waiting for the AMI to be ready. And then eventually once that's done, it's going to then clean up and delete everything. And then now the post processors are going to run. So this is going to create a vagrant box for us. And then it's going to zip that up and archive it, or just zip it up. And here you can see the results. So this is the vagrant box right here. And then this is the compressed version up here. So now that's done, let's go ahead and take a look at the AMIs to see if it actually got created. And so you can see we do have our AMI, which is called my first packer image. And what I'm going to do is I'm going to go ahead and deploy an instance of it just to test it out and see if Nginx was successfully installed on it. So here I'll call this Nginx. And then I'll go under my AMIs and I'll do my first packer image. Key pairs, I'll just do, I have a key pair called test already. I'll use that one. Security group, since this is going to be running Nginx, I might as well allow HTTP and HTTPS out of the gate. And that should be all we need. I'm going to then launch the instance. So now that our server started up, I'm going to open this up and we can see that this is going to be the address. So let's go ahead and test that out and see if Nginx was successfully installed on it, just to show that our image was actually the customized image with the Nginx already installed on it. I'll go to that IP address and we could see the default Nginx HTML file. Okay guys, so that's all I wanted to cover in this video. We got a chance to create our own custom AMI image that had Nginx and a firewall enabled by default, and it shows you just how easy it is to work with Packer to create these customized images. And expanding the configs across, other cloud providers is as simple as just defining a new builder. And so I recommend you guys play around with it and really start to embrace the immutable infrastructure, because that is kind of the direction that we're moving in, especially if you're working with containers, Kubernetes, or really any containerized platforms. They're all making use of immutable infrastructure. So Packer is a very important tool in that ecosystem, especially if you want to stay using VMs instead of containers. And hopefully you guys enjoyed this video, and I will see you in the next one.